Good morning, dear friends. Today's video, once again, I will discuss a few illustration of AP and GP series. So, first question is, how many terms are there in the GP? It is already mentioned this is a GP series, that is 3, 6, 9, 12, 24, up to 384. So, we have to just calculate the value of n. Here, the first term is 3. It is already mentioned this is GP, so we will find out the common ratio. Common ratio, that is 6 divided by 3, it will be 2. So the general formula is an is equal to AR raised by n minus 1. An, this is known as the last term, or we can say this is known as the last term, or an, that is 384 is equal to 3 into 2 raised by n minus 1. Then we will divide 384 over 3 is equal to 2 raised by n minus 1. So after cutting, I am getting 128 is equal to 2 raised by n minus 1. So 128, I can write 2 raised by 7 is equal to 2 raised by n minus 1. So base are same, so power will be equal, and 7 is equal to n minus 1, and 7 plus 1 is equal to n, so n is equal to 8. This is the number of terms. Because the question is how many terms, just we want to find the value of n. So this is the first illustration, and second illustrations, solve 1 square plus 2 square plus 3 square, so on 10 squares. So how we will calculate? We know that the standard result we know 1 square, 2 square, 3 squares up to n square is equal to n plus 1 to n plus 1 over 6. But in our questions, the n is equal to 10. So simply I will put n is equal to 10 in this formula. I will get 10, 10 plus 1, 11, 10 plus 2, 20, 20 plus 1, 21 by 6. So after simplification, I am getting 385. So this is the sum. And next, I will discuss more illustrations. That is, this is the question: 2 square plus 4 square plus 6 square, so on 20 square is equal to. That means we want to calculate the answer. So how the question we can solve? We can simply write 2 square is 1 into 2 whole square. 4 square means 2 into 2 whole square. 6 is 2 into 3 whole square, and so on 2 into 10 whole square. So simply we are observing all the bracket 2 is a common. 2 is a common. So whenever we are taking outside, we are getting 2 raised power 2. In first bracket, I am getting 1 square. In second bracket, I am getting 2 square. Third bracket, I am getting 3 square up to 10 square. So 2 square, it is a 4. And again, this is terms up to 10 square. Like the previous question, I will use this formula, but in this formula, in place of n, I will put 10 because the last term is 10. Simply, I am getting 10 into 11 plus 21 over 6. After simplification, I am getting this one. So this is a strategy. That means firstly, we have observed that what is a common terms. Then we have taken the common term outside the bracket and just we have applied this formula. And the next question, so this is 11 square plus 12 square, 13 square, so on 20 square. Just we want to calculate the value of this function. Actually, if we are talking about this formula, this starts from the 1 square and up to n square. But in our question, the statement starts from 11 square. So for making this formulation, I can add and subtract 1 square, 2 square, 3 square, up to 10 square. That means these terms are added here, and to balance this statement, I have subtracted 1 square, 2 square, so on 10 square. Whenever I am adding in this expression, then terms will become 1 square, 2 square, 3 square, so on 20 square minus this one. So in this bracket, I will use this formula, but in this bracket, I will take n is equal to 20, and here I will take n is equal to 10. So again, I have to use this formula, that is 20, 21 into 41 over 6, and this one 10, 11, 21 over 6. After simplification, I am getting this answer. So this is the arrangement. That means because the statement starts from the 11 square, 12 square. So if we have no such a formula, we have started the statement from this one. I know ki 1 to 10 term is missing. So I have added and subtracted from my side. Then this formulation will okay. Then we can solve the sum by the previous sums as usual. Thanks, dear friends. Please like, share, and subscribe my channel. Don't forget to share with other also.